Hello, this lesson is 7.4. We've been talking about similar triangles, and now we're going to talk about corresponding parts of similar triangles. So the first one is called a proportional parts conjecture. So if two triangles are similar, then the lengths of the corresponding altitudes, medians, and angle bisectors are blank to the lengths of the corresponding sides. Now we had talked about this about perimeter. So this is also true for corresponding altitudes, medians, and angle bisectors. And there's an accidental comma. So they are proportional. That means they have the same scale factor, same ratio as the scale factor of triangles. So how do I apply that? So let's look at these two problems. So again, what do I see? What am I given? So I see that the two triangles are similar. They give you the similarity statement here. Okay. And I can see that I'm also given corresponding pair of sides. I'm also see that I have this, so it says all for the variable. So I must be looking for that. And I can see that this is a midpoint, right? This is equal to that. So this must be this line, a median. Okay, that connects the midpoint of one side to the opposite vertex. So I'm looking over here, A is the midpoint. Right, again, you can see the congruence. So this also is a median. So they must correspond, the x and the 18. So they are in the same ratio as the two sides. So now I can write a proportion. So I can say 12 is to 16 as x is to 18. We're going to cross multiply. And divide. And I have 13.5 centimeters. There you are. All right, so let's look at the next one. So the next one, what do you see? Right, again, similar triangles. So ACB, PRQ, and given a pair of sides, okay, here this is 27, must be for that whole length, and 36 must be that whole length. I'm looking for x, what is x? Okay, so here I can see this is perpendicular, so that's 90 degrees. So when I have a perpendicular from a side to the opposite vertex, this then is an altitude or a height. You can see here for 16, we also have that perpendicular to the vertex, so that is also an altitude. So they are in the same ratio, 16x, as the two sides, 27 and 36. So I'm going to go 16 to x, 27 to 36. Okay, 21 and a third inches. Okay. All right, so that's how you use it. Please really look at the problems in the homework before you jump, really know what they're given and which theorem it applies to. So our next one. This is called the angle bisector opposite side theorem. It's a little convoluted, but it's when you have an angle bisector of a triangle, right? And it divides the opposite side into segments whose sides are proportional to the length of the two sides. So again, we're going to have this ratio. So this side, right, here's my opposite side, and here, right, they correspond with this one and that one, right? So xy goes with yw, and z and xz goes to WZ as stated. Angle bisector opposite side. Okay. So the angle bisector is going to the opposite side. And when you're talking about the angle bisector, remember it's about the angle. So the angle's up here. All right, so we're looking at these. So you can see I'm given a triangle. I can see there is an angle bisector here, right? So it says I'm going from here to here to there. So 14 to x equals 21 to 9. Now remember, we could probably write it different ways as long as the diagonals are across each other. So x equals 6. Now there's no units that they give me, so I'm just going to leave it like that. All right, so this one's different. Okay, so I know that this is going to go with that, but I don't know that much. I know this goes with that one, so I can say 20 to y. Now, 50, is it to 28? That's not right, right? 20 is the whole thing, so I don't want that. So how much is that? Well, here it is. You can write it algebraically. I know that if y was 10, this would be 18, right? You'd subtract 28 from 10. If this was 5, this would be 23. So I would be subtracting y from 28. So this portion here is 28 minus y. All right, so we're going to write that. Okay. Oh, I should have written it smaller. Have some algebra to do. All right, so we're going to cross multiply. And then here when you cross multiply, you can see, yes, you have to distribute. So you have more work to do for this one, but I know you can do it. Okay. Then I'm going to add the 20 to the other side. Oops, that's not right. 20 plus 15 is 35. Okay, so y equals 16. There you are. So again, really be careful. These problems will be mixed in, the ones from the earlier theorem and this one. So really look and see what you're given and which theorem applies to which, and refer to your notes. All right, good luck. Bye.